Hello guys, welcome to my YouTube channel Manoj Networker. So today I'll discuss about symmetric and asymmetric routing. So many network engineers have basic questions on this routing part. So what exactly is a symmetric routing and what exactly is a asymmetric routing? So let's clarify in our today video. So when it comes to network, so network engineers, everyone will always look for redundancy to ensure that our services are always up and running from an end user point of view. So keeping in this picture, so we network engineers always go for a multi-homed router setup or multi-homed firewall setup, and we'll be using different set of routing protocols like EAGRP, OSPF, BGP, RIP to achieve the redundancy. So whenever we have this multi-homed routers or multi-homed firewalls, means we'll be using more and more routers. So either it can go for a symmetric. So whenever, let's consider from your computer. So let me come up with an example. So symmetric routing, it means, for example, this is my source, this computer, and this destination server is sitting somewhere in other building. And you can see there we have multiple routers that are connecting to this server, and we have multiple paths that are available to reach from this computer to server. So let's, for example, symmetric routing means the connection from all the way from this computer to this server will be coming from router 0, router 1 and router 2. And while the return traffic, if the return traffic also will take the same path, so this is going to be a symmetric routing. That means from source to destination and from destination to source again. So a full trip, so if it is coming and using with the same routers, that is called as a symmetric routing. And in the symmetric routing, you will not experience any kind of jitter, latency, nothing, because all the going and coming via the single route. Whereas asymmetric routing means, so asymmetric routing, so going in one path. So if you see from this computer to this destination server, it is using router 0, router 1 and router 2. Whereas while the return path, it will be coming like this. It will be coming like this. So sometimes the computer may talk to server and server can reach this computer. But this kind of situations you will be having asymmetric routing. So asymmetric routing means the going path will be in one path and the while returning path will be using different routers. So in this kind of setup, you will be having a lot of disadvantages, telling the end users may not be able to access the internet properly, or the web services, whatever that is available in this server, may not be able to get through this computer. There will be lot of jitter will be there. So these kind of disadvantages are there in the asymmetric routing. So why asymmetric routing will happen means there may be a poor routing configurations. So maybe in this edge router you may not be configured proper routing because we have so many routing protocols. So that may be a matter here. Or if you are using different kind of routing protocols, that may also create some sort of issues. So whenever you are dealing with this kind of firewalls or this kind of routers, and if you are going for redundancy, so please ensure that all the routers are having identical routing protocol. Either if you are going for RIP, please use RIP. If you are using for EAGRP, please use EAGRP so that we can get rid of this kind of asymmetric routings. So to demonstrate further in my lab, so I'll be using a 7 router setup. So having different multiple from to reach from source to destination. As you can see, there are multiple paths. So from here, this source can go from here to here. So like this, like this. So we have 3 ways. So I'll be using RIP for my routing protocol, and you can see the lab demonstrations along with the particular IP addresses, whatever I'm using. So to demonstrate further, I'll be going to the simulation. So let's see our lab is symmetric routing or asymmetric routing. So I already took one packet from computer, and there will be this will be the destination. So let's see how the packet will traverse. So first things first, so let's start the lab. So as you can see the here events are placing here, and you also can see from the computer the first packet went to the switch. Of course, that it's directly connected. from the switch, I have the default gateway configured towards the router. So first packet went to the router, and from router you can see router 0 pass on to the information to router 1, and router 1 pass on the information to router 2, and that's expected. So and it went to switch 1 because again router 2 is directly connected to switch 1, and finally the packet is arrived to the server. So one way is completed, and again you can see here I am just pinging. So ping is a part of ICMP, that's why the type is ICMP. And now if you see, the return traffic is started from server to switch, and again switch to this router 2 came, so router 2 to router 1 came. So if you see, the packet is going and coming via same same path, or using the same routers. So now if you see, finally the packet is arrived to the switch, and from switch the packet finally will come to the, you can see the tick mark. So this kind of setup is called as a symmetric routing. So symmetric routing, as I said, it will be good for your organization if you configure the routing properly. So I can even elaborate all these things in my next video. Please watch further. Thank you.